Imagine our entire planet just hitting the brakes. Seriously, think about it. We live our lives on this giant rock hurtling through space, spinning at absolutely incredible speeds, yet we don't feel a thing. But what would actually happen to you, to our cities, to our oceans, if that spin just suddenly stopped? Welcome to this explainer, where we're going to dive into the terrifying and honestly fascinating physics of exactly that.
So, what if the world literally stopped turning? Let's dive right into this apocalyptic scenario and figure out what happens the very second the Earth's rotation hits absolute zero. We're going to look at the immediate, catastrophic physics, the massive geographical reshaping, and the slow, agonizing death of our atmosphere. It's basically a masterclass in planetary physics, but played out like the ultimate disaster movie.
1,670 kilometers per hour. That staggering number is the speed the Earth's equator is rotating right now. Now, because we're moving with the Earth, we don't feel this insane speed, right? It's kind of like riding in a car on a perfectly smooth highway. But if the ground suddenly acts like an emergency brake and stops, while the atmosphere and the oceans absolutely do not.
And that brings us to inertia, Newton's first law, stating that objects in motion stay in motion unless stopped by an external force. So the absolute crucial point here is that because of inertia, everything not securely bolted deep into the bedrock is just going to keep flying eastward at supersonic speeds. The atmosphere, the oceans, people, cars, the topsoil, the whole shebang simply keeps moving at the exact rotational velocity of its specific latitude. Let's compare the winds, because this really puts the sheer terror into perspective. Down at the equator, you're hit with winds at 1,670 kilometers per hour. That means absolute obliteration. For context, the absolutely strongest F5 tornadoes ever recorded cap out at around 511 kilometers per hour. So these inertial winds are over 3 times stronger than the worst storms in history. Even up in mid-latitudes like New York or France, winds would still be screaming at nearly 1,180 kilometers per hour. It's total devastation. Literally, the only places offering any mild safety would be the extreme north and south poles, since their rotational speed is practically zero.
You might be wondering, what about buildings? Well, skyscrapers built for complex load dynamics would instantly tear right from their deep foundations. Even our most advanced architecture, carefully engineered to withstand immense dead and live loads, stands zero chance against supersonic gusts. The lateral forces would just be way too massive. Buildings are uprooted and huge concrete structures are torn apart like tissue paper.
As the astrophysicist Neil deGrasse Tyson so bluntly put it, people would be flying out of the windows. It's a brutal reality. Humans, cars, man-made structures, we'd all just become deadly projectiles instantly scattered across the surface. Now, you wouldn't fly off the Earth into space, actually. The escape velocity needed to leave Earth's gravity is roughly 40,000 kilometers per hour, so you're nowhere near that. Instead, you'd just be thrown laterally at devastating speeds alongside billions of tons of debris. Now, what's really fascinating is how the sudden loss of centrifugal force fundamentally changes the actual shape of our planet. Centrifugal force is that outward apparent force created by rotation that counteracts gravity. Right now, Earth isn't a perfect sphere, it's an oblate spheroid. Because it spins, that outward force pushes the mass of the Earth, especially the oceans, outward at the equator, creating this massive equatorial bulge of water. So let's look at the timeline. At t+0 seconds, rotation halts. By t+5 seconds, that equatorial bulge totally collapses. Without that outward spin holding the water at the equator, Earth's gravity just takes over. By day 1, it pulls those massive oceans violently toward the north and south poles. We're talking unimaginable mega tsunamis racing away from the equator and completely erasing global coastlines. Fast forward 1 month and you're left with 2 massive polar superoceans, leaving a brand new, bone-dry supercontinent wrapping right around the planet's middle. And guys, it's not just the water moving. We are looking at total geological chaos. The solid Earth wants to shift from an oblate spheroid to a perfect sphere now too, so the crust buckles and splits. As gravity pulls the rock inward, it triggers massive global earthquakes of unprecedented magnitude. Tectonic plates are grinding together, resulting in super violent, unorganized volcanic eruptions. Even dormant craters would literally burst open as the molten core struggles with that sudden massive shift in momentum. But hey, amidst all this terrifying destruction, here's a wild, counterintuitive little piece of physics for you: 0.3%. Surprisingly, without that centrifugal force pushing outward and counteracting gravity at the equator, you would actually weigh about 0.3% heavier if you were standing on that new, dry equatorial supercontinent. Your actual mass hasn't changed at all, but the effective pull of gravity on you is just a tiny bit stronger. Okay, so what happens to the cycle of day and night? If you somehow miraculously survived the 1,600-kilometer-per-hour winds, those mega tsunamis erasing the coastlines, and the crust literally buckling beneath your feet, well, the next threat comes from the sky. Because we're still orbiting the sun, a single day now stretches into an entire year. You get this intense, permanent shift. 6 months of sun means blistering, boiling heat on one side that evaporates any remaining fresh water. And on the flip side, 6 months of darkness, a frozen, eternal night. And those extreme temperature differences between the boiling side and the freezing side, they'd whip up catastrophic, continuous global storms.
It pretty much goes without saying that flora and fauna ecosystems would totally collapse under permanent daylight or total darkness. Plants completely rely on the delicate balance of day and night for photosynthesis and rest. Animals rely on circadian rhythms. These extremes would obliterate global food chains basically overnight. The only survivors left on this alien version of Earth might be deep ocean extremophiles or underground microbes completely shielded from the surface.
Section 1. The final shield falls. The collapse of Earth's magnetic dynamo.
So let's step through this. Step 1. Earth's rotation ceases completely. Step 2. The molten core's dynamo effect dies. See, deep inside the Earth, a molten iron core is constantly churning, driven by the planet's rotation. This creates a massive dynamo effect, generating our magnetic field, our shield against solar winds. Step 3. Without the spin, that magnetic field decays. And finally, Step 4. Lethal solar radiation bombards the surface. Even if our atmosphere somehow survived those initial winds, the sun would just slowly strip it away into space, leaving Earth a barren, irradiated rock, kind of like Mars.
Our spinning planet is a delicate, perfectly balanced machine, which begs the question, what else are we taking for granted? This explainer really highlights just how fragile our existence truly is. A sudden stop to a rotation we don't even feel, and life as we know it is instantly erased. It leaves you wondering, right? What other invisible, monumental forces are keeping us alive every single second of every single day? Definitely something to think about the next time you watch the sun go down. Thanks for joining me on this one, and I'll catch you next time.